Okay, so this is the key to section 7.4, part B. All right, here we're adding, subtracting rational expressions, and notice that the denominators are not the same. So at some point, we're going to have to find the LCD. Okay, so number one, notice that these are two rational expressions. You can write this as 2 over 1, just like this. And the first thing you want to do is factor the denominators before finding the LCD. So this denominator is a monomial, that's just 1. This denominator I can't factor, that's just x plus 5. So the LCD is going to equal x plus 5. Alright, so now what you're going to do is write two equivalent fractions using that LCD. So I'm going to write two fractions with that denominator, just like this. And this is an addition, so I'm going to use a plus symbol here. Okay, so I want to know 2 over 1 is equivalent to what fraction with that denominator? Now remember, each of these fractions are equivalent to an infinite number of fractions, but I'm interested in the one that has this denominator. So look at what you had and what I need. I had a 1, I need an x plus 5. So what's missing is the x plus 5, is the factor x plus 5. So what I'm going to do is I'm going to multiply this denominator by x plus 5. Now remember, what you do to the denominator, you're going to do to the numerator. So 2 has to be multiplied by x plus 5 as well. So again, make sure you put that in parentheses. So basically what we have here is 2 times x plus 5. That's what we have here. All right, and you can always check yourself if you were reducing. You don't though, because you're going backwards. If you were to reduce x plus 5 divide out, you end up with this 2, and that's what you wanted. Okay, over here, notice this is what I had, this is what I want. They're the same thing. So this denominator and the fraction I want to end up getting has the same denominator. So what that means is that if the denominators are the same, then the numerators have to be the same. And it kind of makes sense because if I want to, just like I did here where I multiply this denominator by a factor, so if I want to multiply this denominator by a factor, that factor would have to be a 1. And so x times 1 is still x. Alright, now this is going to be the easy kind because you're adding. So now since the denominators are the same, I can write this as one fraction with that denominator. So I get, and I go ahead and distribute. So I get 2x plus 10, 2 times 5 is 10. So 2x plus 10 plus x, and then combine like terms, I get 3x plus 10 divided by x plus 5. Now remember, the next step would be to factor the numerator. Now always keep your denominators in factor form. Factor the numerator because there's sometimes a chance where when you factor, you can divide out some common factors. But 3x plus 10 I can't factor, so that's the answer. So 3x plus 10 divided by x plus 5. Okay, over here, again, the first thing you want to do is factor your denominator. So here I can factor out an x, and I get x times 3x plus 2. Here I can factor out a 4, and I get 4 times 3x plus 2. So if you look at all your factors, my factors are x, 3x plus 2, 4, and 3x plus 2. So in terms of the LCD, in terms of your monomials first, x and 4, I'm going to end up getting 4x in my denominator, in my LCD. This factor is 3x plus 2. There's only one factor here. Remember your exponent. One factor here. There's only one factor here, so I just need 1. So there's your LCD. So now what you're going to do is going to write two fractions with that LCD, with that denominator. Now be careful with this one because this is now going to be a subtraction. So we get 4x times 3x plus 2. 4x times 3x plus 2. Okay, so let's look at what I had and what I need. I had the factors x and 3x plus 2, so that's this. What I'm missing is that 4. So I've got to multiply this denominator by 4, but what I do to the denominator, I have to do to the numerator. So 4 times 4 is 16. So that goes here. Over here, I have the 4 and the 3x plus 2. I am missing the x. I'm missing the factor of x. So I got to multiply this denominator by x, and what I do to the denominator, I have to do to the numerator. So 3x times x is 3x squared. And now since the denominators are the same, I can write this as one fraction with that denominator. So 4x times 3x plus 2. And I get 16 minus 3x squared. Now that subtraction wasn't that bad because this was just one term. So just rewrite it. Now don't make the mistake and think that this is the difference of two squares because 3 is not a perfect square. So there's nothing you can do there. There's your answer. All right, so you get 16 minus 3x squared over 4x times 3x plus 2. Now just to remind you, if you wanted to put the x squared term first, you got to be careful. You got to keep the sign. So if you wanted to, you could have said negative 3x squared plus 16 divided by 4x times 3x plus 2. But that's all you can do. All right. So don't make a mistake and say that's 3x squared minus 16 because it's not true. All right. So that's another way of writing the answer. Now there are a couple other ways, but that's the two main ones. All right. Now let's look at number 3. Okay, factor your denominator. I get x plus 2 times x plus 2, which is the same thing as x plus 2 squared. And then here, that's the difference of two squares. So that's x minus 2 times x plus 2. So your LCD, okay, now this factor x plus 2, there are 2 here. There's only 1 here, so I need 2. The next factor I see is x minus 2. There's 1 here, none here, so I need 1. So that's your LCD. So now I'm going to write two fractions with that denominator. Write two fractions with that denominator. And that's going to be easy because that's an addition symbol. So you're adding those two fractions. Okay, so I have the x plus 2 squared. I'm missing the x minus 2. So I got to multiply this by x minus 2. In parentheses, don't forget to put that in parentheses. And what I do to the denominator, I have to do to the numerator as well. So x minus 2 times 6x, I'm just going to rewrite as 6x times x minus 2. Okay, over here, I have one factor of x plus 2, but I need 2 of them, and I already have the x minus 2. So what's missing is the factor of x plus 2. But what I do to the denominator, I have to do to the numerator. So this numerator right here is going to be x times x plus 2. All right, now I can write this as one fraction. So x plus 2 squared times x minus 2. Now let's go ahead and distribute this. So that's going to be 6x squared minus 12x. So 6x squared minus 12x plus, all right, that's going to be, if I distribute the x, that's going to be x squared plus 2x. All right, combine like terms, I'm going to get 7x squared. A negative 12x and a positive 2x is a negative 10x all over x plus 2 squared times x minus 2. Now, remember the next step was to factor your numerator to see if you can reduce any factors. Now, you could do this in your head and notice that if I were to take out an x, it wouldn't help. The factors, none of these factors up here would divide out with anything down there. So you could leave your answer like this. Now, if you wanted to go ahead and factor the numerator, you can. You would just have x times 7x minus 10 divided by x plus 2 squared times x minus 2. So either one of those would be a solution. Okay, over here, factor your denominator. That's going to be x minus 3 times x plus 2. Here, that's going to be 5 times x plus 2. So your LCD would be, okay, in terms of your monomial factors, that's going to be 5. I have an x minus 3, one factor here, none here, so I need a factor of x minus 3. I have an x plus 2 here, an x plus 2 here, but I just need one of them. So there's your LCD. So your LCD is 5 times x minus 3 times x plus 2. All right, now you're going to write two fractions with that denominator. Now be careful, this is subtraction. All right, so two fractions with that denominator, so 5 times x minus 3 times x plus 2. 5 times x minus 3 times x plus 2. All right, so now we're going to write equivalent fractions. This fraction here is equivalent to what fraction with this denominator? Well, I'm missing the 5. I have these two binomial factors, but I'm missing the 5. So I got to say times 5 and then times 5. Now make sure you put that in parentheses because all of these terms have to be multiplied by 5. So really you have 5 times x minus 1. Over here, it looks like I'm missing the factor x minus 3. I have the 5 and the x plus 2's. I'm missing the factor x minus 3. So I gotta say times x minus 3. Make sure you put that in parentheses. X minus 3, make sure you put that in parentheses. So it looks like I have 4 times x minus 3. Okay, now I can write this as one fraction with that denominator. And then distributing here, right here, I'm going to get 5x minus 5. All right. Now, be a little bit careful here. You're subtracting all of this. Okay, you're subtracting all of this. So that's where you have to be careful with subtraction. So you're subtracting 4x minus 12. Okay, now get rid of the parentheses so you can distribute the negative 1 now. So you're going to get 5x minus 5 minus 4x plus 12 divided by 5 times x minus 3 times x plus 2. And then combine like terms, 5x minus 4x is x, a negative 5 and a positive 12 is a positive 7 over 5 times x minus 3 times x plus 2, and that's all you can do. So the answer is x plus 7 divided by 5 times x minus 3 times x plus 2. So that's your answer. All right, so that's the key to section 7.4, part